So listen carefully. I am not anticipating that these will be awesome because you are rusty, not great at FRQs yet, whatever. Okay, so the purpose of you doing 2 at night and then us going over them is that you have seen them and are familiar with them before we go over them. The goal is not that you get 9 out of 9 points. Does that make sense? That phone needs to be away. Thank you. So the plan is to do 2 every night. So these first 2 FRQs were rate in, rate out. That's very common. You will probably see that on the practice exam that we're going to take as our final. You will probably also see that as one of your FRQs at the end of the year. Very common type of problem. Typically calculator active, but not always. So usually question 1 or question 2. Okay, so we're going to go through this one. We're going to see how it's graded, make sure it makes sense, and we're going to practice these 2, and then you're going to do another one tonight, and hopefully the one tonight will be better. Does that make sense? Okay, so don't stress out if they're not amazing. The more you do FRQs and see how they're graded, the better at them you get, because you start to anticipate. It's like they don't ask every single calculus question in an FRQ. There's like certain types of questions they typically ask in FRQs, and so once you look at enough of them, it starts to narrow you down and you get ideas on how to answer FRQs because you're like, oh, they never ask that, they always ask this. Does that make sense? Okay. So for the first one, they're telling you, is this the first one we did? No, this is the second one. Okay, so the first one we did has people entering an escalator and then people getting off the escalator and all that stuff. The first part of the question is for the first 300 seconds, you should have 0 to 300, R of t dt equals 270. Plug that straight in your calculator. I'm going to show you a little calculator trick. All right, so go ahead and get your calculator out if you haven't already.
Do you have to write 270 people to the line, or did you just say 270?
Probably 270 people is fine. Okay. Yeah. And they didn't say units, that you had to have units, so you probably would be even good with 270.
And just writing R of t is good.
Okay, so one thing that I've been learning more about my calculator as I tutor calculus students at different schools because different calculus teachers know different tricks. So here's one trick that I learned that I really liked. Go ahead and we're going to plug this in. We are not going to graph it, but we're going to plug it in right here. So I'm plugging it in my graphing screen even though I don't really care what the graph looks like. And I'll show you why in a second.
We're just doing RT?
Yep. So I'm plugging this in for Y1, and I should see everyone doing that. So the benefit of this is that when you type this into Y1, you can see all of it at once, and you can check, and you can say, yep, I'm good, I've got no typos. And now we're going to use Y1 on the normal screen, so we never have to type this again. Does that make sense? So I'm typing it. Yeah, I showed you that before, but I didn't do it in this context, and so I'm just showing you that it still works in this context. Okay, so if I get out of that, now if I want to do the integral, I can do math 9, 0 to 300, and I can type Y1 instead. And if you guys remember, there was that faster way to get to Y1, which I learned after I taught you. It was alpha trace. That can get you right there. It's faster. I learned that after I taught you guys the long way. So alpha trace gets you to Y1. We typed the Y1 in terms of X, so I'm going to say in terms of X. This way I just don't have to keep typing that function over and over again, and it's kind of a complicated function, and so it's easy to have a typo. So this way I type it once perfectly, I make sure it's perfect, and then from here on out, anytime I need that, I just do Y1. Does that make sense? Now, we'll talk more about the grading in a second. You can get the exact same grade on this if you write R of t dt or if you write this. But with this, if you miswrite it, you won't get the point. So it's safer to write R of t dt. All right? It's not more or less accurate, it's just safer because we're not going to miswrite something as easily. Okay. For the next question, they said that we had 20 to start with, 20 people in line to start with. Did you guys see that? That's our initial value, plus the number of people who come in during the time from 0 to 300. And then we're going to say minus 0.7 times 300, and that's because people are exiting the line at a constant rate.
Do we have to do all of that at one time, or could we say, could we have broken it up and done like
I'll break down the grading in a second. So right now we're just checking to make sure we got the math. So if you type all of that in, you get 80 people. All right. For part C, again, we're just checking for the mathematical accuracy right now, and you don't necessarily have to fix your paper. I would almost say I'd rather you not fix your paper because we're going to grade our own in a second. So don't fix yours, leave it the way that it is. And if you're already fixing it, that's fine. We'll just not fix the rest of them because you will have access to an answer key. So you will always know the answer to this question. You'll have access to an answer key, but I want to grade yours as it was when you first did it. Okay. All right. So next I have 20 to start with, the amount coming in minus the amount going out, and I want to see if it's ever 0. So what I did is I just said 290, that was all the people coming in, minus 0.7 t equals 0. And then I went ahead and I just solved for t, and I got 414.286 seconds. There are multiple ways to approach that problem. That's just how I approached it. Okay, but that is the answer that you should have gotten.
What if we left this?
Wait for the grading questions in a little bit because we're not grading yet. Yeah, it's fine. Yeah, we can make little adjustments. Okay. To find the minimum number of people in line, we have to take our expression that represents the number of people in line. And the reason that I'm rewriting this expression every time is because I'm just keeping in mind setup is sometimes part of the number of points, and so I'm always going to include my setup. Okay, so I said this was the expression for how many people are in line. You'll see in a second. And then I said I have to take the derivative of that. Now the reason I have two different variables here is because I'm talking about t as the specific moment in time that the minimum value is happening. And I can't have t as a bound and t as a variable. Does that make sense? So since I said t is the number that I'm solving for, that I'm trying to figure out what the minimum value is, then I had to write a different variable here. Your other option could be that you could write all of this in terms of t and then change that to a different letter and change this to a different letter, but they technically would. One of them still represents a variable and one of them now represents that minimum value. Does that make sense why I switched it? Okay. So then I said I'm taking the derivative of this entire thing. When I took the derivative of 20, I got 0. When I took the derivative of this, I was doing the second fundamental theorem of calculus. This is a bit of a reach, honestly. I think when I first did this problem, I probably did not get part D, to be honest. Okay, so I did the fundamental theorem of calculus right here, so that's where I got r of t times 1 minus r of 0 times 0. You see that? So I'm taking the derivative of it. And then I'm taking the derivative of negative 0.7t, and I just got negative 0.7. So when you simplify all of that, you get r of t minus 0.7 equals 0, so r of t equals 0.7. So what I did then is I got my calculator out, and I said I need to figure out where r of t equals 0.7 from 0 to 300. So what I did is I went in my window, I did 0 to 300. And for my y's, you could do 0 to 0.7. I did negative 1 to 1, I think, so that I could see everything. And then I forgot to do it, but I need to graph 0.7 to see where they cross. So we can do second trace number 5. And I'm finding that intersection. So if you hit the up and the down arrow, you can hop between the two lines. It's going to be easier for me to scroll if I'm scrolling on the 0.7 line than if I'm scrolling on the other curve because I can't even see that one. So I hopped over to 0.7. I'm just going to go ahead and find that first intersection. And so that's that first answer, the 33.013. And what I did, whenever I store a number as something, I always write down on my paper what I stored it as. This is not like math notation that everybody uses. This is like Miss Rice notation. So I wrote down 33.013. I stored that as A. So what I did is I got out of the screen and I hit X to get that decimal on my screen. And then I went ahead and I stored it as A. Make sense? Okay. And then I went ahead and I graphed it again.
And once you store it as something, it no longer, like whenever you put X, it's just...
Yeah, whenever I put X, so as soon as I go and find this other intersection, it's going to replace that original X with a different number, which is why I didn't store it as X, because that X is constantly being replaced.
Once you store that as A, X is no longer 3.30 or whatever.
No, it's still saved under X until I save X as something else.
Does that affect how you do problems?
So that's the reason that whenever I'm plugging in a numeric value, I never use X, because whenever I plug stuff in, I'm always using X as a variable, and I'll show you in a second how to differentiate. I think I know what you're talking about. I'll show you in a second. I'll show you when I get there. All right, so that was my other intersection. I can't see it anymore, but it should still be there. Okay, so this was my other one. I stored this one as B, right? So now it wants the minimum value of those. So this is talking about, if we're talking about relative minimums versus absolute minimums, we want the absolute minimum because we want the shortest number of people in line. Does that make sense? That's not just a small amount for like that timing. That's like overall what's the shortest amount of people that there was in line. So I'm including the endpoints and I'm including those two values that I got because I'm remembering the extreme value theorem. You guys remember that when we find absolute mins versus relative mins? So when I found the 33 and the 166, that was kind of like me finding my critical values. I took the derivative and I set it equal to 0. So this part right here is me taking the derivative and I'm setting it equal to 0. And I got it by using my calculator to solve that for me.
Why wouldn't you have earned the points for using the second fundamental theorem?
We're not doing points at all yet. We're just going over.
You said that earlier.
What?
That when you said you did the second fundamental theorem.
No, I said I probably didn't get points for this question because I don't think I knew how to do it until I looked at the answer key. Okay. So that's how I came up with my values. The way that I figured out which one was a minimum is I was plugging all of these in and getting the values out. So I knew that at time equals 0, there were 20 people in line. And I knew that at time equals 300, there were 80 people in line. And so I already had those Y values. I already had those numbers. So the only ones I had to check were the 33 and the 166. So for me to check to see how many people were in line at that time, I needed to go back to that equation we've been using to figure out how many people are in line at an exact moment. And so I had to say, but my time is going to be from 0 to 33, and then I'm going to subtract off 0.7 times 33. Does that make sense? Okay, so when I go back to type this in my calculator, and Grace, this is going to answer your question. When I do from 0, and this time I'm going to do from 0 to A, that's from 0 to 33. Now when I go in and I use that Y1, now my X is the variable because Y1 is in terms of X. And when I put X here, I'm saying X is in terms of a variable. And so that's why I did not use X to store my number because X can't be a variable and a number at the same time. It's got to be one or the other. Does that make sense? Yes. Y1 is that function that I had stored right here. Okay. So, and the reason I'm doing that is I just don't want to have to keep typing it over and over and over again, and this way I don't have to. So now I can do 0.7 times A. So this is me plugging in my 33 to see what my Y coordinate is right there, how many people are in line. I get 3.083. So there's 4 people in line at that time. Now when I want to go back and figure out the other one, I can just grab this and plug B in instead of A. $158 people in line. And so that's how I figured out that the time was 33 seconds and there were 4 people in line. Does that make sense? Okay. What I'm going to do now is I'm going to hand out, these are actual samples of students who did this question and then got graded on it. So these are students who took this FRQ that year. Yes? Probably. I do it because I want to see it on the screen and make sure I have the right number and then store it. But if you have done it enough and you're like, I know it's right, then you can go automatically to that. Yes.
Are we grading ours?
Oh yeah. Do you guys want to take a moment and grade yours?
No.
All right. So this is the second question. So it says how many pounds of bananas are removed in the first 2 hours. So I've got the integral from 0 to 2. I did the same thing that I did last time where I plugged the equation into the y equals so that I didn't have to keep repeatedly typing it. And I got 20.051 pounds of bananas the first 2 hours. Then it asked me to find the derivative evaluated at 7. And that's the thing that I kind of liked about this too. Let's go ahead and plug this one in just in case we're going to do some more from this problem. Mm-hmm.
Wait, you can do the derivative on the calculator?
Yeah, I showed you guys a couple times. I think we're just like having varying. All right, so go ahead and type this in as y equals.
No.
You can calculate the derivative through the graph. I generally don't do that because then you have to find the right window, and that can be kind of crazy. So what I did to find the derivative of this one is I did math 8. I wrote my problem in terms of x, so I've got the x right there. And then I went ahead and I did alpha trace. I've got my y1 in there, and I'm evaluating it at 7. So again, I've got it in my y1. I checked it and made sure that in my y1 that I didn't have any typos.
Wait, it's math 7?
Math 8.
Math 8.
Mm-hmm. So the derivative at 7 was negative 8.119 if you do truncated rounding, or 120 if you do like rounding with the rules. And then I said 7 hours after the store opened. That's what the 7 means. Yep. You can do 3 or more.
If you did 8.12,
you would not get the answer. Yeah. It's not sig figs, it's 3. Just do 3. Just do 3. They might give you the 8.12. I have noticed that, but I wouldn't even risk it. I would just do 3 every time. Yeah. So 7 hours after the store opened, that's what you need that. The rate that the bananas are being removed from the display is decreasing. So don't say the number of bananas is decreasing. Say the rate that the bananas are being removed from the display is decreasing by 8.120 pounds per hour, because this is an acceleration per hour squared. You could say that. Okay. All right. For part C, it wants to know if the number of pounds is increasing or decreasing. F of t is a rate of change. G of t is a rate of change. We don't have to take the derivative of those because those are already rates of change. Does that make sense? So what we need to see is just that the amount coming onto the display and the amount going off of the display, we need to see if that's a positive or a negative value. Okay, so you need to do G of 5 minus F of 5. So the amount going onto the display minus the amount going off of the display at 5, and that's a negative number.
Could you just find G of 5 and F of 5 and see which one is larger?
You could do that. So since that is a negative number, I said, therefore, the number of pounds of bananas on the display is decreasing. This right here, this less than 0, that's my justification. Doesn't have to be words, it's calculus, right? Less than 0.
F of 5 is greater than G of 5?
You could probably say that. Mm-hmm. So that's for part C. For part D, I have 50 because the original display had 50 pounds. 50 minus from 0 to 8 of f of t, so minus the total amount that's coming off, plus from 3 to 8 of g of t, because the bananas only started being replaced on the display after 3 hours. And then if you do that, you get 23.347 pounds. So this problem, I feel like this problem was a little bit better. It didn't have that part D. Part D wasn't crazy to me on this one. I think when I originally did the problem, I did the derivatives of these. Not thinking about how they were already rates of change. I think that messed me up for part C.
I started to do that, but then I was like,
no, these are already rates. Yeah. Yeah. But the setup is a point, so that's always good. I think most of the time it depends on the problem.
and how good
So for this, like, if you did G of 5 minus F of 5, and then you didn't actually put the answer, you just put it was less than 0, you get the points?
I think as long as you put it less than 0, it should be okay. It kind of depends how they say that they're grading it. Okay, so we're going to go ahead and grade this person. Well, these 3 people.